Hello everyone, myself Sandeep Birla. I'm pursuing my Masters of Engineering in University of Wollongong in Mechanical Department, and now I'm going to give a brief explanation about my research topic of joining the hybrid dissimilar metals by friction stir welding technique on roll cages in a racing car. So let's get into the contents of this research topic, where I'm going to give a brief about all these topics later in the video, of which the introduction is first explained. As according to my research, when I was given a topic of welding racing car joints, I've done the mind map where I got to consider all the parameters, all the things that are in the welding in the racing cars, of which my main interest gone through the roll cages, because roll cages are the main structures of the race cars that ensure the safety of the race car drivers. So there are many risks that are experienced by the race car drivers because of the impacts, as racing is a motorsport. The high speed crashes are common, so these may lead to many accidents, and some of these accidents may lead to death of the race drivers. So according to my research, first I have done my research on head injury criterion, which is one of the first one that I have evaluated before going further. So in the head injury criterion, some dummy models of different heights and weights are taken and placed in the cockpits and were experimented, so that we can know the safe limit for the driver of the car. So what is the speed limit with the current roll cages can be known. So within the current roll cages, it was known that the safe limit for the driver in a car is around 11 meters per second. So if the speed increases 11 meters per second, it means that a driver is going to meet an accident or experience an injury, and it can lead to death. So my idea about dissimilar metals. So after considering the head injury criterion, I have considered the idea about dissimilar metals based on the needs that are expectations that have to be met by the automobile industry, like considering the materials in the roll cages that has to be corrosion resistance and low cost and high productivity, and have good mechanical properties and have low ductile properties, so that the metals do not get cracks or deform. Next, after that, I have considered the types of weldings. As I have considered the dissimilar metals, these are the welding techniques that I have to consider in order to join the dissimilar metals, of which fusion welding, low dilution welding, and non-fusion welding are the main three methods, of which fusion welding is the conventional welding technique that has been used from too long. But these fusion welding here in these fusion welding techniques, we use filler materials in order to do the welding process. But as you see in the dissimilar metals, doing the fusion weld and lead to the melting of the base material. So we do not consider the fusion welding, because as we are using two different materials. So next we consider the low dilution welding materials. These give a good result, but they are high in cost, because laser beam weldings in two materials it lead to high cost. So these two techniques were not considered. So non-fusion welding was considered, in which friction stir welding is the best method which can meet the requirements of the race car. So here I'm going to give an explanation about the friction stir welding. Friction stir welding is a solid state welding technique where FSW2 is going to penetrate in between the two materials. If it is a lap joint, it is going to be used like in between two, as you can see in the diagram, that in between the two materials the welding is you can see the joining of the welding. If it is a butt joint, it's going to be penetrated inside the tool, so that the joint can be formed. So these are the things that we have. These are the main parameters that have to be considered, like tool geometry, welding parameters, and heat generation and material flow while considering the dissimilar metals. And these are the properties like high rotational speed, tool rotational speed. If the tool rotation speed increases, the mechanical properties also increases. And this friction stir welding has low melting points that is mainly required for designing a roll cage. So after that, as I have considered my welding technique, now I'm going to select my dissimilar metals. So before doing that, I have done an investigation on frontal crashing impacts, where impact attenuators are designed in 3 research papers for every frontal crash. Like even in the nose cone of a race car, the impact attenuator is designed, where these impact attenuators are evaluated numerically and experimentally. Numerically by using LS Diana, a finite element code, and experimentally it is done by using drop testing machine. So based on the experiments, it was known that both the numerical and experimental results are nearly equal. In these researches, the composites are mainly used. So this research has led to know that the kinetic energy is absorbed more, and based on the acceleration versus time graph, you can see that the simulation of the LS Dyna, it shows that the deceleration impact attenuator is reached to 20 grams in 40 milliseconds. So it shows that meets the requirements of a racing car. So these are the previous works on the fabrication of dissimilar metals, where I've considered there are two metals. One is a polycarbonate and another is an aluminum alloy, which are welded using a friction stir welding tool by using two thermocouples, and polycarbonate is placed on the aluminum alloy, and 2 thermocouples were placed on the top of each to know the thermal properties and the surface flow properties. And you can see the diagram of the weld that has happened, and there is a stir zone formed. But according to this research, it was known that at stir zone there are shrinkage bubbles formation, which cause to the formation of cracks that lead to the deformation of the joint. So now I'm going to give my research design based on the gaps that I have been explained before. So based on the literature review and the previous findings, it was known that aluminum, magnesium and glass fibers are mainly considered. Impact attenuator is fabricated by using these materials, and these specimens were tested using drop testing machine experimentally and LS Diana code numerically. So hereby, and according to my conclusion, that the surface energy absorption increases, and this leads the hybrid composite to withstand the impact of the crash, and this joint is light in weight and meets the requirements of a racing car. So these are the references that I've used, and thank you so much.